Hello everyone, Mike Silverman here. In this Babylon.js video, I'll show you how you can create a character out of multiple different parts, so it looks like your characters are changing their armor or their clothing. How we're going to do that is we're going to have a main skeleton file with the skeleton and the animations for our character, and we're going to have separate other files that have the mesh for the part that we want, for example, the legs or the torso, and it's also going to include the exact same skeleton. When we import the part, we're going to delete the skeleton from the part and make its skeleton be the skeleton that has the animations on it. So it's going to be like those parts are attached to the skeleton. For our local development environment, we're going to use Vite, which is a bundler that includes a hot reload feature, and it also sets up TypeScript for us locally very easily. I did try to set up TypeScript on my own with Babylon, and it was quite challenging. So I decided to go with Vite. It's a little simpler than something like React, which I've also used with Babylon, but for such a small demonstration, I think this will be perfect. And of course, you can set it up however you want, but we are going to copy this command if you want to follow along with how we're doing it or how I'm going about it. And we're going to go over to our terminal. We're going to paste that in. And whatever directory you run this command in, it's going to create a subdirectory, which is going to be your project folder. So we can give it a name, and we want to choose vanilla, and we want to choose TypeScript. Now it gives us some instructions here. So we want to go into that folder, and we want to run npm install. We also are going to want to install Babylon and Babylon loaders to help us load some files. Okay, so we should be able to do npm run dev, and that's going to give us this URL here. We go there, we'll see that we have the starter page that Vite starts you out with. So here is the project directory that Vite made for us, and we are going to do some modifications before we can get properly started, mostly deleting some of the stuff that they already give us. So we're going to go to the index HTML. We're going to go down to the title and just delete the title. We are going to delete this div with the ID of app. We're going to leave this script tag here, importantly, because that's how we're going to get our JavaScript in here. And then we're going to add a canvas here. This canvas is going to have an ID of Babylon canvas or whatever ID you want. You just have to remember what it is for later, because that's how we're going to attach our scene to this. And we're going to style it. Since there's going to be such few styles in this project, I'm not going to make a CSS separate file or anything. We're just going to do some inline styling because, just should be more straightforward. So we want, we want to make this height 100 VH, width 100 VW, and we want the background to be a nice color. You could pick what you want, but I've been doing 022 hex code. That's kind of a dark green color. And if we save that, it should be almost good, but let's go take a look. So I'm gonna turn off dark reader for this. So that is the color we'll get, and it looks pretty good. So we can see that this is our canvas if we inspect it. We can see there, that's kind of hard to read. I realize that, so let me zoom that in. So maybe a little more. So you can see this is our canvas and it's taking up the entire screen, which is exactly what we want. Okay, so now let's go and look at the source folder, and we're going to delete some things in here. The counter TS, that was that demonstration application that you can increment a counter that Vite starts you with. The style.css, we are going to delete it, and that's going to cause an issue for us that I believe we'll see in a moment, but we'll fix it. And then we're going to delete this TypeScript SVG because we also don't need that. And in main TS, we are just going to select everything and delete it. Now if we go look here, we have this border going on, and that is to do with the default CSS that HTML comes with. So we need to add something to the body to remove that. Vite came with that already in their CSS file, but their CSS file is really long and unnecessary for what we're doing. So we're going to go here to the body. We're going to add a style tag to that. And we're going to say padding 0, padding 0 px, margin 0 px, and box sizing border box. So this is a CSS thing that makes all elements include their border, which I don't think that matters for us, but I always like to put that in because that's kind of a default setting I always work with. Okay, so that went away. And we are good to go to start working on our JavaScript. Back in the source folder, we're actually not going to use main for the moment. We are going to create another file called game world. And here we're going to create a class called game world. And this is going to contain basically the entry point for most of the logic for our Babylon app. So in our game world, we need a scene, which is going to be of type scene from Babylon.js, which automatically imported. Right. Then we're going to get an engine, which is also going to be something from Babylon. I'm going to name it with the correct spelling. Then we're also going to store a camera, which is an arc rotate camera. And in our constructor, we need to take in a canvas, which is going to be a HTML canvas element. We're going to set our engine to a new engine. We have to pass in the canvas, and we'll turn on anti-aliasing. Then we're going to create a new scene and store it on this object where we pass the engine. Finally, we are going to get a camera object to set to our camera through a function that will set up our whole scene and return the camera from it. And we haven't created that function yet, so we're going to have to do that. So let's go create a separate file because it's going to be a bit of code, and it's going to be code that you're most likely already familiar with, so I'm just going to paste that in. So here we are basically setting up a camera. We're attaching the control to the canvas, changing the speed at which you can scroll the camera because it's a little bit too fast. Setting up a light, changing the intensity of the light, changing the position of the light, and making another point light. So we have a kind of more directional light here. And we'll also make a ball mesh that's just going to be a sphere that kind of shows the position of that light. We also have some ground, which is just going to be a square, and we set what color it is, and then we will return the camera out. Now we're going to add that function to our game world class. So we just go there and we say equals init scene equals init scene, where it gets imported just like that. So with this, we should be able to attach the scene into our canvas. So let's head over to our index, or actually our main.ts here, and we're going to get the canvas element. And the ID that I named mine was Babylon canvas. So something about Vite that I'm just remembering here is that when you set up the project, it'll give you an error for any unused variable. If you don't like that, which I personally am not a fan of it, you can go to change that in the top level of the directory, tsconfig, and under linting, you can change this no unused parameters to false and no unused locals to false. Then if we go back to here, we just get a warning, which I much prefer. So now that we have the canvas, presumably, we're going to make an instance of the class of the game world that we created. And when we do that, we need to pass the canvas. And it's going to give an error because it thinks it's HTML element, but we know this is a canvas element, so we can cast it as HTML canvas element. And that should work. So let's go take a look at the browser. Okay, it's not working because I forgot something, which is we need to start the render loop in our engine. So we are going to do that right here. So we'll say this.engine.run render loop, and we pass this a function, which we'll call this.scene.render. And if we go back to the browser, we do have an arc rotate camera, we have the ground, we have this light, the sphere that has the light in the same position, so it shows us the position of it. And that is a pretty nice starting point. So back in our game world, we are initializing our scene, and now we want to spawn a modular character. So this is going to be an async function because loading meshes in Babylon is asynchronous. And here's where we're going to spawn our modular character. So we know that our character needs to have a skeleton, so we want to import that skeleton. We'll await it because we know this might take some time. And to do this, we're going to call a custom function that we're going to wrap the Babylon loading function with, just so it will be easier to load things, because we're going to be loading a lot of things. Okay, so we're going to create this function, and the asset path is just a placeholder that I wrote in here because we don't know what the asset path is yet. We actually have to do some work in a content creation tool like Blender, which is what we're going to use. And then we're going to know where we save the asset, and we'll pass it here. So let's actually adjourn from this for the moment because we have to get our actual skeleton GLTF, and we have to do some things to it. The models I'll be using are from quaternius.com, which offers many high quality free assets for using in games. And when we get here, we want to go to the search bar and type modular. And we're going to click on the Ultimate Modular Women Pack right here. We'll scroll down to the download link. Of course, you can support them on Patreon. And we're going to continue to the download. This brings us to a Google Drive where we want to go to individual characters folder. We want to go to the blends folder. And we're going to download whichever one you like, but I'm going to use the witch and the medieval model. So we'll click download and download, and then you can wait and see when they finish. Okay, mine took a few seconds, but it finished. So we'll go move those files to somewhere better than the download folder. So I decided to put my blends that I downloaded in a folder within the same project just to keep things together for this, but you can choose wherever you want to put them. And then we're going to have these blend files. We want to open them in Blender, and it doesn't really matter which one you pick first, but I'll start with the witch. And now we have this character that is very nice because it has different parts, and you can see if you click on them, they are actually highlighting the collection of meshes as separate parts. So if you're designing your own character, you just want to make sure that your parts line up perfectly. You can see in the middle here that the torso and the legs line up at the waist. And for each type of clothing you make, you'll want to make sure it lines up correctly. We just want to export the skeleton only. And I realize it is kind of hard to see this, so I'm going to see if I can increase the size of the UI. Okay, much better. So we want to only get the skeleton here. So we can look over on the side here and we can see what we have. So we expand character armature, and we see we have the body, the feet, the head, the legs, and the armature, which I believe contains, yeah, that contains the bones. So to export only the skeleton, we're just going to hide the parts we don't want at the moment by clicking these eyeball icons. And now we have just the skeleton showing. And if we hit A on the keyboard, or you could just draw a box around this, then we can export everything that we are selecting. So we'll go to File, Export. We're going to use GLTF format. And we do want to make sure animation is checked, and it should be checked by default. And we're just going to call this humanoid skeleton. Anything else under here? Probably, oh, right. So we have to also include only selected objects. Then I believe that should be good. Let's just double check everything. Mesh we don't care about yet, but we will check that box later. All right, let's just go with this for the moment. And if I'm wrong, we'll fix it later. Okay, so that should be exported. And mine exported to the same directory that I opened the blend file from. So we're actually gonna want to move that. So we can cut that and we'll go to our project directory and we want to use the public folder because files that are inside this folder will be served. So they'll be accessible to our code. So we'll go in here, we'll paste it. I noticed the Vite SVG is still in here from the setup, so I'm going to delete that. So now we should have access to our humanoid skeleton file in our code. Now that we have that, we're going to create our custom import mesh function. So under this spawn modular character function, we'll add another async function. The option we want to take in, or the argument, is file path. That's going to be a string. And this is going to return the Babylon function scene loader import mesh async. Oops. Okay, I have to import that from Babylon to get the autocomplete. And here we're going to pass nothing for the first argument. We're going to pass something we're going to define called base file path as the second argument. We're going to take the file path from the function signature and pass that along. And then we're going to pass this.scene as the final argument. Now, you could just always call it like this, but I find that to be kind of a long thing, and I'd rather just only pass one argument each time because I know the base file path is always going to be the same. The scene's always going to be the same. This first argument, which I believe tells you which meshes you want to get, yeah, the mesh names, it's always going to be the same. And I'd rather just save some text here. So we save that. We do have to define the base file path. I'm actually going to put that into a separate file. So we'll create a new file called asset paths. And in here, we're going to export base file path, but later we'll come and we'll export a lot of other file paths so that we can store them all in one place and we'll never type the wrong file name in the code. So now we can go back and we're going to import this into this file here. And now we have this handy little wrapper here. So going back, we can finally uncomment this. And instead of asset path, we want asset paths, which we've yet to define, dot skeletons, dot humanoid. So this is going to be in that same location that we just created. So we can just go to definition on this, and that will bring us here. And here's where we're going to name all the different parts and our skeleton. Okay, this is the file name that we exported from Blender, and now we should be able to load this. So let's go back to here, and we have to import asset paths. So now we should be loading a skeleton. Let's just see if we get any errors. Refresh it just to be sure, but it should be auto refreshing. Okay, so we're not getting any errors. Let's make sure we're actually calling this function. We're not. So let's actually call this function. So we're unable to load it. And that is probably because we didn't import the Babylon.js loaders, which was one of the packages that we downloaded in the very beginning. So the place we're going to import that is going to be in main. And at the top of the file, we'll just say import Babylon.js loaders. And hopefully that will fix the issue. It looks like it's gone. So we do supposedly have this skeleton here, but of course we can't see it at all. To actually see our skeleton, we're going to attach some red cubes to it, which will help us visualize what's going on. And before we actually do that, we're going to create our modular character class, because that is the class that's going to include the method that will draw the cubes, as well as some other ways that are going to manage the modular character. So we'll create a file called modular character, and we're going to export a class called modular character. So the character is going to need to have a skeleton, and the type of anything that's loaded, the way we're loading it is scene loader async result. We can see that because when we load in the game world, that is this type of skeleton. So that is what's returned from the scene loader import mesh async. This is going to include the animations and the meshes and the bones for the skeleton. Something else we're going to include in here is going to be the parts, but we'll get to that later. And we also need to keep a reference to the game world. So that's going to be of type game world, so that when we change the different parts on this character, we'll be able to spawn using the scene that's stored in the game world. And we'll implement that later, of course. But right now we need the constructor. And that's going to take in the world. And it's going to take in the skeleton. And we're going to set this dot world. I guess we'll just do that right now, but we won't use it yet. So one way we can clean this up a little bit is just make these public variables, and then you can delete them from up here. And now we don't have to assign them in the constructor. They automatically get assigned when they're passed in. So in the constructor, we want to show the bones of the skeleton, which is a function we're going to create, but we'll just type in that we're calling it for the moment. So this dot show bones. Now I need to declare that function. Since it's a method, we don't need to write the word function. So here we're going to get some cubes and attach them to the bones. So let's make a cube size variable. That's a pretty small cube, which is perfect for us. We're going to make them red. So now that we know what size and color the cubes are, we need to actually find all of our bones. And to find all of our bones, we're going to search the skeleton for the root bone, which is called root. And I know that because in Blender, you can see that. So I'll show you that. If we take a look under armature, root, And you can see there's a bone icon next to it. So this is the node that is the first bone, and every other bone is going to be a child or grandchild of that node. So we're going to look for this by name, and if you have a different name here, like you could rename it to something, or you create it with a different name, then we'll just have to choose a different name in the code when we look for it. So let's look for it with our custom function that we're going to create, which is going to be called get child mesh by name. And we're going to pass in the parent mesh, which is just going to be the first mesh that's stored inside the skeleton that we loaded. And we're going to pass the name of the thing we want to find, which is root. And then we have to create this function. And where we're going to create that is going to be in a utilities file. So I'll just create a file called utils.ts. And we're going to export a function called getChildMesh by name. We're going to take in a root mesh, which is, I forget what the type is, so I'm going to go take a look. It's an abstract mesh, so I'll just copy that type here. We have to import that from Babylon. And then we're going to take in the name of what we want to find. It's just going to be a string. And here we're going to loop through all of the descendants of the mesh that we got passed, like so. So for const node of mesh.get descendants. And we want to pass false because that, for some reason, it's not importing, right? Okay, right. So we have to say mesh or abstract mesh. No? All right, give me a second. I'll figure it out. Okay, silly me. This is actually root mesh. This is the variable we got passed here. And I typed get the sentence wrong. And we typed false because otherwise it won't recursively search them. So you could see its direct descendants only is a Boolean. So I guess you don't actually have to pass it because it's going to default to false, but being explicit is a nice thing to do. So as we are looping over every single node, we see this is a node. Nodes have names, so you can say if node.name equals the name we're looking for, then we're going to return that node. Otherwise, if we loop through everything here, we'll return undefined automatically, but I like to just return it explicitly. And now we have this function that should find the mesh of whatever name we pass to it. So let's go back to our modular character and we can import that from our utils file. And now we should be getting the skeleton root bone, or if there is nothing named root inside it, it'll be undefined. Now that we know our root bone, we can make another utility function that's going to paint cubes on all of the descendant nodes of that root bone. So we'll make another utility function called paint cubes on nodes, and we're going to create that in the utilities file. So here we need to get the cube size, which is a number, the color, which is a color 4, and we also need to get the scene so we can spawn cubes, and we also want to get the root node, which is going to be of type node. So you might not get a warning for this being undefined. For example, if I delete that from here, you don't get a warning, but you do need to import it because node is uh, different things for different libraries. So we want to make sure we're getting the Babylon JS version of the type node. I'm also going to make this the first argument. Okay, so we need to create a cube that we're going to attach to each node, but we have to loop through each node first. So for const node of root node get descendants, we're going to create a bone marker cube. Mesh builder, create box to make a cube. And the first argument is going to be the name. I'm just going to call it node cube, and then the name of the node. Next, we're going to pass the options. So for a box, you can set the width, height, depth, and the colors of all the faces. We want width, height, and depth to all be the same size, which is going to be the cube size. Face colors is an array with a color for each side of the cube. Since there's 6 of them, we can use the array fill syntax. So new array, 6 elements long, and we want to fill those elements with the color that we pass in. So they'll all be the same color. Finally, we need to pass in our scene to the create box function so that I can add the box to the scene. Now we want to attach this, and the way we're going to attach it is by setting its parent. So bone marker cube, set parent. And we're going to set its parent to the node. And we also want to change its local position, because if we don't do this, it will show it in a not perfectly lined up with its parent. So bone marker cube dot set position with local vector, and we want to make new. I wonder if you can do zeros. No, you can't. Maybe there's vector 3 dot 0. Yeah. Okay. So we don't need to write new. We just write it like that. So this is a vector with all zeros. Now we should be able to go back and call this function. First, we'll import it. We're going to pass our root node, which is the skeleton root bone. We want the cube size to be the size we defined earlier. We want red to be the color, and the scene is going to be this.world.scene. And we have an issue. Okay, so we can't pass undefined, of course. So we'll just check if it was undefined, since get child mesh by name might return an undefined thing. So if skeleton root does not equal undefined, or if you want to be fancy, you can just do that. And yeah, so we should be able to show the bones now. So we can call it in the constructor of the modular character. So when we make a new modular character, it should show the bones. And now we have to make our modular character. So let us go back to the game world, where we call spawn modular character. First we create the skeleton, and now we can make a new modular character. And this is a little bit of interesting JavaScript information. So you might think, why don't we just take this and put it in the modular character constructor? And that's because a constructor can't have promises in it, so we can't use a wait, because a constructor needs to immediately return the object. To get around this, you could make a function called init, where you set the skeleton to be some, like, this would be asynchronous. But that would mean you'd have to say that the skeleton is either null or the result. of a scene loader, and I never want there to be a null skeleton in a modular character. So rather than do that, we are going to have this separate spawn modular character. So hopefully that was an interesting side note about JavaScript class construction and why you can't do asynchronous things inside of the constructor. But anyway, so we will create that skeleton and now we'll make a new modular character. And we have to pass it the skeleton. There's also something else we pass it, the world. So we'll pass this because this is a method of the world. So this refers to the world. Okay, so do we call this function? Yeah, we do. All right, let's see if we're doing it. All right, we are. So here we have our character playing its death animation. That just happens to be the first animation in the array that our Quaternius's models comes with that we downloaded. Since it's a little bit too much motion for my liking, we're going to change the default animation to the idle animation. So to change the default animation inside of the modular character constructor, we're going to have our skeleton, and we want to change the animation of that skeleton. So what we're going to do is go to its animation groups, 0. We know it's playing 0. That's the default. So that's the death animation. We're going to stop that. And this is where you have to kind of know the position of your animations. I know the idle is the 4th one, just from experimentation. And when we call start, you want to pass the loop, which is default to false, but I want it to keep playing, so I'll pass true. So now any modular character we create should start off in the idle animation. If we go back, we already automatically refreshed thanks to the Vite setup. And you can see these are all the bones, which corresponds to our skeleton that we got from Blender, and it is playing the idle animation, which you can also play in Blender if you press space. All right, so that's pretty cool. We got our setup going on, and we can see that we are indeed importing our skeleton. So the next thing to do would be to import some parts and attach them to the skeleton. If we want to attach parts to our skeleton, then we need to export some parts. So in Blender, we're going to turn back on the visibility of certain parts that we want to attach. So we'll start off with the legs, and I'm also going to include the feet in this. So to export these, we want to make sure we select them, and we also want to select the skeleton, but an easier way to do that is just to hit A on the keyboard, and now we're selecting everything that is visible. Now we're going to go to File and Export, GLTF once again. We do not want to include the animation in this because we already are going to be loading the animation, and that could take up a lot of extra bandwidth and in-memory memory. So we're going to uncheck that, and we are going to make sure that include selected objects is checked. Then in data, under mesh, we want to make sure we apply modifiers. So one of the modifiers that was used in this model is the mirror modifier, which copies the left leg to be a mirror image of the right leg and other parts like that. So if we don't check this, we'll only get half of our model. And I believe that should be everything, because we're going to be exporting the model and the skeleton. So it has to be the exact skeleton, and if we don't have the exact same skeleton, you're going to see some interesting effects when you import your models. So making sure that we do have the exact same skeleton and everything looks good, we're going to export. And I think I forgot to name it the right thing, so let me just check what I named it. Yeah, so I named it humanoid skeleton, but we want to name it something else that we know what it is. So this is the witch legs. And then I'll take that and I'm going to put it into the public folder. So now we want to attach this part. So we're going to create a function inside our modular character class called attach part. And this part is going to take in our string, or this function is going to take in the part path that is going to be a string, which is going to be the file path. So we want to load that up. And since we're using await, we have to make it async. And here we're calling import mesh, which is our custom wrapper. And we're going to use the world, which is why we have world as part of our modular character class. So now we'll have that part loaded and we want to attach it. So to do that, we'll do a few things. First thing we got to do is set its meshes skeletons to be the skeleton that we already loaded. So we'll loop through the meshes that are in this part. If there is no skeleton for this mesh, we can continue the loop and just not run this iteration of it. Otherwise, we're going to make this mesh's skeleton be the main skeleton that we already loaded. This skeleton referring to the skeleton of the modular character. And this skeleton is actually a scene loader async result. And those results include an array called skeletons, and that 0th index of that would actually be the skeleton itself. And then we want to say, well, actually, let's start off with that for the moment. And we're going to find out something interesting that it's not going to quite work just yet. So let's actually call the attach part function. In the constructor, we can call that. So we'll say this dot attach part, and that's going to be asset paths dot, well, we didn't add it to this yet, so we'll go over to asset paths and we'll say legs and then which, and that's going to be which legs dot glb. So this will just be a nice way to access this without having to type a string directly in our code. Okay, so we should be attempting to attach it, but I do happen to know it's not going to work yet due to some interesting nuances of Babylon's loading of GLTF files. So, but we can take a look, see what it looks like. Okay, so we did load in the legs, but they are not really moving. Yeah, you can see they're not moving. Our skeleton's moving, but the legs aren't getting attached to it. We don't have any errors either. So what is going on is actually, even though we can see there's a skeleton here, Babylon doesn't consider it to be a skeleton because these nodes are, there was no mesh attached to the nodes when we exported them. And the only way for Babylon to realize that something's a skeleton is for there to be a mesh associated with that skeleton when you export it. And you might think like, why is the animation working then? I believe it's because the names of these nodes match up with the animation data, so they're actually moving them around based on the name of the nodes. But since it doesn't recognize this as a skeleton, we can't set these legs skeleton to be that skeleton. So we have to actually change a little thing about how we exported our skeleton to begin with, which we're going to do next. So in Blender, we want to export our skeleton again a little bit differently this time, and we want to include a mesh that is associated with the skeleton. So we're going to we're going to hide the visibility of our witch feet and our witch legs. We're going to show the witch head for a second, and we're going to duplicate this head because this is going to be, let me just duplicate it with Shift D. And by holding Shift and pressing D on the keyboard, I got this duplication of the head. We'll hide the original head because we actually want to save that, but this head we're going to change to be a very small, tiny mesh. So not being a super Blender expert, the only way I know how to do this is to go into edit mode. So I press tab to enter edit mode. You can see that we're in edit mode right there. And we're just going to start deleting most of this. Let me select it, delete the vertices. And this could take a minute, so I'll probably fast forward here. Okay, so I deleted everything except for this quad here. And this is probably not the most efficient way to do it, but the reason I did it this way is because I know that this mesh is associated the with the skeleton and has some animation data associated with it. So we're basically going to trick Babylon into just giving us this skeleton, and we'll have this little thing here to delete inside of Babylon, but it shouldn't take up too much memory in the grand scheme of things. I couldn't figure out a better way to do it. And yeah, so this should allow us to actually see the skeleton in Babylon as a skeleton when we export it. So once again, actually, you know what? Let me rename this to be just uh, placeholder mesh. So we're going to select every, oh, let's go back to object mode. So we can hit tab or select it with this dropdown. Hit tab, no, sorry, hit A, select everything. When in object mode, hit A and select everything. Now we'll go to File, we'll export again, GLTF. We do want the animation data. Remember, we just exported the legs without it, so we have to check that back on. We should be the same for everything else. Selected objects is good. Data, mesh, apply modifiers. I, we are exporting a mesh, so I don't think this matters, but I'm going to leave that on. And the name is correct, actually. We want humanoid skeleton. So let's export it as a GLTF. And before I bring it from the blends here, this is the new one. And this is the one we're using right now. I just want to show you that it thinks this skeleton is empty. To show that, we're going to go to the attach part here. And before we do any of this, we're just going to log out this .skeleton.skeletons. And just to be clear what we're doing here, we could put a little string before it. Now, my hypothesis is this will show as an empty array. So if we go over here, we could see that it's an empty array. Now, what will happen once we import the new one? Let's find out. So we'll go to wherever you exported that. We can copy it. Go here. We're going to overwrite it. So paste it, overwrite it. And now we can see it is actually attached and the legs are moving. So this is a pretty big moment for us. We've got a part that is attached to our skeleton, which is very cool. And you actually do see the array is populated this time. So we tricked it like that. Now there is one kind of issue is that there's this tiny little thing up here, but we can delete that. So there you can see that. It's hard to zoom in on it. Also, the controls in Blender are different than the arc rotate camera. But anyway, you probably see it right there. It was getting called. Yeah, we can't zoom in too much. But okay, so we have to delete that. That's one thing. But we're kind of, on the right track here. So we have to delete that. There may be something else we have to do to fully attach this, but right now it is looking good. So the issue we're going to run into is that if we try to move this character, the legs will not follow the position of the skeleton. And to demonstrate that, we're going to modify our spawn modular character function just a little bit so we can set the start position of characters when we spawn them. So in the spawn modular character function, we're going to take in a start position, which is going to be a vector3. And we'll give it a default property of vector3.0 so that it just defaults to no start position. But what we'll do is we'll set the skeleton's position to that once we create it. So after we create our modular character, you could even do it before if you just want to directly set the skeleton. We'll do it after. Character dot skeleton dot meshes 0. So that should be the top parent mesh of the skeleton. And everything else should follow its position. We'll set its position to be start position, which is going to do nothing for the moment because it's starting out as 0. But when we pass that in here, when we actually call the spawn modular character, let's make a new vector3, and we can say, let's do that 1 0 0. So we'll move it by 1. Okay, so let's take a look at that. And we could see if we rotate the camera, we did change the position of our skeleton, and the legs are still animating, but they're not following the actual position of our skeleton. So we're going to change the modular character to account for that. For when we attach parts, we're also going to set their parent to be something that will follow the correct position for. So let's go to our modular character, and inside the attach part, we're going to get a parent that we want to set. We'll do it up at the top, and we're going to get a transform node by name, and we're going to pass this .skeleton, and the name of the node we want is called character armature. So a couple of things. First of all, we haven't made this yet, but we will in a second. And what is character armature? Well, if we go into Blender, we can see character armature is the top node of the entire thing we're exporting. So in the skeleton, it won't have these meshes, but it will have this character armature, and that's going to be the thing that we change the position of, and we can follow the position of with our parts. So let's create this function, and we'll do that in the utils file. So here we get in a scene result and the name of the transform node we want. And we'll just loop through all of the transform nodes in the scene and return the one that has the correct name. And if it doesn't, we'll just return undefined, which JavaScript would automatically do anyway. Now let's go back and use this function. You got to import it. And now we'll be getting a transform node, allegedly, if we knew the right name for it. So what we'll do is while we're also looping over all the meshes inside of our part, we'll set their parent to be that node. And it has to be defined. So what we can do is say that probably you shouldn't do this, but we'll do it for the example because it's quick and dirty. We'll just tell with the exclamation point that we know that that's not going to be undefined. If it is, we'll get an error and then we can fix it. But we know that this should be in there. So now let's take a look. If we go back, we are still moving the position, and you can see the legs follow the position this time. If we take that away, they didn't follow the position. So we know that that is working. So one other thing we want to do in the attach part is, since we're setting the skeleton to a different skeleton, we can get rid of our original skeleton that we don't need anymore, the one that we exported with the part. So once we've looped through everything, we can say part.skeletons 0.dispose. And this might be undefined, so I'll just put a question mark there. For some reason, I don't know why it's not telling me. Like, indexing into an array could always be undefined, but maybe the linter settings are different in Vite than my personal project. But in any case, there's going to be one other thing we'll do here, which is going to be to remove the old part. Now, there is no old part at the moment, but once we start switching parts around, we are going to need that, but we'll just leave ourselves a to-do here. The other thing we want to do real quick is just to remove that placeholder mesh that we're using to make Babylon recognize our skeleton as a skeleton. And to do that, we'll go back up to the modular character constructor. And here, once we start the animation, we're going to get rid of that mesh. So to do that, we can say while skeleton dot meshes dot length is greater than 1. We want to keep the one mesh, which is going to be the root, but we want to get rid of that extra one. So we say greater than 1 to keep the first one. Then we're going to say skeleton dot meshes pop to get the last element of an array. And we're going to call dispose on that, which is a Babylon method to get rid of something. And since this could be, it knows that pop could be undefined, but it doesn't realize that we're saying that the length has to be greater than 1. So we know that pop will not be undefined because that would be impossible. Unless you can fill an array with undefineds, which is a very JavaScript thing to do, so maybe it's not impossible. But we'll say that we know that it is impossible, so we can get rid of that. So now if we take a look over here, you should see that that little thing is gone. And if we take it away, that thing is there. So we'll leave that like that. And now we won't be rendering unnecessary meshes, and also it will look a lot better. I also want to put this back in the center. So let's go to the game world and set our start position to be, well, let's just not pass the start position because we have a default setting for that. The other thing I want to do is make this rotate towards the character, so we can easily do that by taking also in a start rotation, which is going to be a number. And here, just like we set the position, we'll say rotate. And rotate takes in the axis around which it will be rotated. So we'll say vector 3.up. And the number that will rotate is the start rotation plus, I want the default to be facing at the camera. So, also, well, anyway, math.pi /2 divided by 2. So that should be a quarter turn. If it turns them the other way, I'll put it as a negative, but I actually forget. So as far as the start rotation, we can't put a required property after an optional property. See, like that. So we're going to give this a default to be 0. And now we are facing directly towards us. And if we want to start ourselves with a different one, then we could say this is a function. Okay, then we can do it like that. And yeah, we spawn them inside of each other. But there you go. You can make different characters and start them in different positions like this. For the moment, though, we'll not use our second character. Now we've come to the part where we need to get a bunch of different parts of our character and export them to actually move forward. So I'm going to fast forward through exporting a bunch of different parts. So yeah, before that though, I'll show you one more time how you do that. So back in Blender, you want to turn on the visibility of the part you want. Click in this window, make sure you're in object mode, hit A to select all, File, Export, GLTF, do not export the animation data. Make sure you only include selected objects. And on the data dropdown, mesh sub dropdown, make sure you do apply modifiers. And then you want to name this whatever you want. I'll name mine which torso. And I'm going to export a whole bunch of different ones real quick. And I exported the head, the legs, the torso for the witch and the medieval models. And remember that every model you get has to have the exact same skeleton, which quaternious models in the modular pack that we downloaded, they do have the exact same skeleton. Now, let's make a little modification about how we spawn our character, because when we create a new modular character right now in the constructor, we're attaching a part, but I actually don't want to just attach whatever part I write here, because I want it to change from each character. Like I want to be able to spawn it with such parts that I tell it to when I spawn it. So we'll delete this from here actually, and we'll leave this constructor, and we'll go back to our game world. And inside the spawn modular character, this is actually where we're going to attach the different parts. So here we'll say attach parts. But what parts are we going to attach? Well, we're going to get the path for the different parts. So for here, we won't write anything at the moment, but we'll actually take in that as some arguments. So here we'll take, we'll leave these as the later arguments since they have defaults on them. So you have to put the ones that you actually have to define up top here. So we'll say legs path, it's going to be a string, torso path, string, and head path, string. And here we'll attach each of those parts. Now here we have to say what parts we want. So here's we'll say asset paths. I forget which is first. Legs. I'm actually going to make it go head first, then torso, then legs. It'll be a nice top-down ordering. So we'll say asset paths dot. Oh no, we didn't define our asset path. So here we have to add the things we added or that we exported. So we'll say okay, so assuming these are all spelled correctly, we should be able to access those here. So spawn modular character, first thing we want is a head, and we'll go with which for this character. Let's give them the medieval torso, and let's give them the witch legs, because I think they're the coolest legs. Now let's see if we got any errors. No, we didn't. Okay, so there we go. So we can now pass in and create a character of whatever combination we want. So let's call this character 2, or character 1. And let's also make a character 2. And for this character, we'll give them the medieval head and the witch torso. And we're also going to put them in a different position. So this would be vector 3, new vector 3. And I think we want to put that is 0, that is 0, and that is 0.6. That's pretty good. They put it next to each other, which is what I like to see. We can also change their rotation if we want. Give them a little side rotation. Actually, negative. And of course, you can play around with it however you like. Maybe I'm having a little too much fun with it. Okay, so I think that looks pretty cool. And we can spawn our different characters like this. So now we want to work on being able to change the parts around. Because when you equip different armor in the game, you want to see it put on the new armor and delete the old armor. And for that to happen, we have to set up a little more in our modular character class. All right, so we know that every time we attach a part, we need to remove the old part. So we're going to create a function that is part of the modular character class that can remove parts from itself. We'll call that remove part. And here we're going to get a part category, which is going to be a type called modular character part category, which we're going to create what that is in a moment. So what is this? Is an enum that's going to say the different types of parts there are, and then we're going to store references to our current parts by category on this character. So first, let's just create that. We can go up to the top and just store it here. So we know we have head, torso, legs. And we're going to make sure that we store our parts here. So this is, we finally got back to this here. So what parts is going to be on our modular character is a record. And if you have never seen record before, a record is just an object with key value pairs that includes one of each thing that its keys could be. So since it's a record of modular character part categories, then each one of these will have to be filled with something. And it's either going to be null or a modular character part category. And we're going to start this off with an object that's going to have one of each of the part categories. And they're all going to equal null for the moment. Get the correct syntax there. Okay. Oh, this is a mistake. So it the keys are modular part categories. The values are either null or an I async an I scene loader async result. And that's how we'll be able to dispose of it. Because if you don't keep a reference to this, you won't be able to dispose of it later. So now that we'll have this as part of our modular character, when we ever attach a part, we want to save that scene result into this object. So here, when we attach a part, actually underneath this, we're going to say this.parts part category equals part. But we don't have the part category yet, so now we need to take that in as an additional argument when we attach a part. So now, whenever we attach a part, we'll know whatever part category we said it was, and we'll attach it just like we were, and we'll save it. So now we can remove it when we attach another part from that category. And you technically could pass the path to something that was not in its same category, like we could call this the legs and pass in a path to a torso. But it shouldn't matter because if we ever attach another thing of that category, we'll delete the same thing of that category, which I guess you could end up in situations where you have characters that look like they have like two legs and no torso. So something to consider and be careful of when designing your game. But for now, I think this will be good enough. So when we remove a part now, we can actually remove the part that we know is in that category. And the way we're going to do that is by using the Babylon built-in dispose method on everything that's inside the iasync scene loaded result interface object that we are saving. So we have to get that. So we'll say to remove equals this dot parts part category. And this could be null or it could be the thing we expect. So if to remove is null, then it's already removed. So we can just say return. But if it's not, then we're going to dispose of it. So there's no like part dot dispose, or there's no to remove dot dispose method, unfortunately, like there is on a scene. Since we loaded it in the async await syntax, we have to go and manually dispose every single thing. So we'll create our own function for that, and that is going to be called dispose async loaded scene. I did ask them on the forums about this, and they said this is what you have to do. So uh, maybe if you're watching in the future, there'll be a nicer way to do it. But for now, we'll just pass in our object here, and we have to create this function. We'll create that in the utils file. So down here, say export function, and we're going to take in a scene result. And basically, we're going to take everything in here and call dispose on it manually. So there is a little gotcha here that if you try to do it like this, then it could leave some of the meshes behind because while it's iterating over the for each, meshes will be removed and then the index is changing. I don't quite understand it exactly, but I was informed that we should try to do it a different way with a while loop. So instead of doing it like this, we'll say while scene result dot meshes dot length. So as long as it's not 0, as long as there's still something in this array, then we're gonna pop the last thing on the array, and we'll have to give it the exclamation point to just say we know there's something there, and then we'll call dispose on that. And that should remove all the meshes. Now there's not only meshes inside these scene results, so there's like 5 different things. So scene result.meshes, let's see what else there is. We know there's skeletons. We know there's transform nodes, and I could see everything there is because of TypeScript like autocomplete here. Let's get rid of all the lights. Let's get rid of everything. Okay, so that will basically remove the entire scene result. And we can now use that by importing it. And whenever we remove a part, it will basically remove that. Then we also want to set our reference to this part to be null. So we'll also say this dot parts part category equals null. So let's find out if it actually works by removing a part after a delay on the spawn character function. So let's go back to game world, and inside of spawn modular character, right, we've changed this, so we have to actually change. So this is a modular the part category. I think we're not exporting the enum, that's why it's not showing up. So let me just go back here, and we have to export this. There we go. We'll make sure that's the legs category. Okay, so if everything's working as before, it should be good. It is. And then we'll just delete one of these parts or remove them after a time. So we'll set timeout, and we'll pass this function. and we'll say character dot remove part, and we'll remove the torso. And that means our first character should, wait, where's the character two? Oh, I'm mixing up things. Okay, yeah. So all of the characters should do this. After 1 second, we should see, let's just make it 2 seconds. We have a second here. Interesting. Seam result dot meshes dot pop is undefined. So in any case, it worked and it's not frozen. Maybe I can figure out what that's all about. Okay, so I renamed all of these variables, but I kept referring to meshes for all of those. So I'm just going to quickly fix that. And now I think that error will go away and we can remove parts nicely. So now if we can remove parts, that means we can switch parts out. So back in our modular character, we're going to make sure that whenever we attach a part, we remove our old part. And we want to remove the part that's in the same category as the part that we're attaching. And then we should be able to switch out the different parts. So here in our set timeout, where we say character.remove part, we can, actually we're going to take this out of here because I want to just create the modular character, but in the constructor of our game world, we'll set the timeout so we can change these different characters. So we'll set the timeout here. We'll say character one, attach part, and we will give it a torso, and we'll send it the asset path, torsos, whichever one it's not using. It's using medieval, so we'll give it which. And it says attach part is not a function of it. Oh, I see. We haven't awaited for these. So, okay, so here we're going to get into why you can't do async things in a constructor, because this is a promise right now. We can't call await on this because we're inside a constructor. So we are going to make that init function that we alluded to earlier. So we'll take everything here where we create our characters, and we're going to call this .init characters. And this is going to be an async function. So now here we can call await. And it still does not like that. And that is because we never return our modular character here. So at the bottom of spawn modular character, we actually have to return the character. And now we should see that we have the attach part method, and we could see that there's some problem that I didn't foresee here. Alrighty, so I found what it is. It is right here. I'm saying that these head are actually legs, so yeah, you gotta be careful with that. So let's see if we save that. We're all good. And then if we do like this, we should see our one character's armor change. And there it goes. So now we basically see how we can do that. We can change our character's armor. But what if you want to put a weapon or some kind of equipment into their hand? So to do that is actually not too bad. But first we're going to need a model of something. So we'll go get a sword model. On Quaternius' website, if you search for modular weapon, you can get the modular weapons pack. And we'll go down to download, and you can continue to download. we'll go for the blends, and we will go with a sword blend. Sword blend. Here it is. So we will download that. Once that's done, we'll open it up in Blender. And this sword is going to be way bigger than the characters. So I'm just going to hit A to select it, S to scale it, and make it pretty small. Maybe like 1/3 of the block size there. And then let's hit A, File, Export, GLTF. Make sure we don't need any animation data, although I doubt there is any in here. Make sure we include selected objects. And for the data, we want to make sure apply modifiers is checked and export it. And that should give us a sword GLB here. I'm going to change it to lowercase s because everything else I have is lowercase. Then I will bring that file and put it into the public folder with all my other assets. And now we should try to look at how we're going to attach this sword to our character's hand. So looking back at our modular character, we want to make a new function that is going to be equip weapon. And here you could take a file path name, but we're not going to use it. So let's put an underscore there so it doesn't give a warning for the unused variable. Because we are only going to use this one sword just for the example. If you were to expand this to a real game, you would probably want to figure out a better way to do that. Maybe you could make like an enumeration of all your different type of weapons and key them to the file paths. But for us, we're not going to do that. So let's make our weapon, and we're going to import it. With our custom importing wrapper here. It's just sword.glb. And let's see if it's even the right size. So first we have to call this actually. So we will call that in the spawn modular character function. Right here when we attach the parts. I passed an empty string because we put that placeholder variable. Okay, the sword is itty bitty tiny right there. So I might go fix that real quick. Okay, so I'm spawning a more reasonably sized sword. I just went into Blender and upped the scale for that. Uh, Real quick though, I'm noticing that if you open the console and then close it, the Babylon scene gets all kind of spread out because it's not resizing. So we can actually fix that super quick here. So we'll go over, we'll leave this undone for the moment, just because that is going to bother me. And we'll go to the main here, and we're going to say window dot add event listener resize, and we'll put a little function here that says world dot engine dot resize. And now we can open the console and it is not looking too bad. We can even do something like this and it's very reasonably resizing. And what we just did is we took the window object, which is just available because we're running JavaScript in the browser and the browser provides the window object. We call the add event listener method to add an event listener, which is something that you can put functions on. Resize just means the browser always knows when you resize it, so you can listen for that. That's one of the provided events. And then you pass the function where we call the resize method that Babylon provides. Okay, with that out of the way, let's head on back to equipping a weapon. So if we want the weapon to be attached to our character to make it look like they're holding it, we basically just want to attach it to one of the bones that's in their hand. And I found that a good bone to attach it to is something called wrist R, which is the right hand wrist. And I'll show you what that is in Blender. In Blender, if we look at our bones here, actually, instead of looking at it like that, we'll use this sort of view here. So let's first of all hide the witch body so we can get a better look at this. If we go to, okay, I had to change the UI scale back here, but in the top here, there's a little tiny plus sign where you can add a different workspace. Go to the General tab and choose Layout. And that is because the blends that are downloaded from Quaternius, they just don't have this as the default Blender layout, and this is how we're gonna look at the different bones. So I can change the UI scale back real quick. Okay, so now we should be able to change to edit mode. No, I'm really struggling. Okay, so maybe I didn't have to do that. So you just click on one of the bones and hit tab, and now we can go into looking at the bones in the T-pose here. So if we kind of move on over here, we can see there's this bone. It's not really the bone I want, although you can use that. There's a tinier little bone in there that we want to get a look at. Okay, so it is this. So this is where we're going to position our weapon relative to, and if you click on it, you can see it says wrist R up there, but if that's hard to read, you can hit F2 to rename it, and you can see the name of the bone. Depending on your skeleton, you'll have different bone names, so you just want to find a good bone that's kind of near their hand, and it's going to follow the hand movement in a way that is going to make sense for swinging a weapon. So let's go back over to here, and we are going to get the bone that we're going to attach it to. And the way we'll do that is by using one of our pre-made helper functions from the utilities file. So equipment bone is going to be get child mesh by name. And the parent mesh is going to be this.skeleton.meshes 0. And the name we're looking for is the name of that bone, wrist R. So this should give us that bone, and we're just going to parent this onto that bone. So we can say if there is an equipment bone, indeed, because it could be undefined if we type the wrong name, then we'll say weapon.meshes0.parent is going to equal equipment bone. And if we look over here, it is sort of attached to their hands, but it looks really weird. It's kind of like some Assassin's Creed blade, which is cool, but we want to make it look like it's more in the palm of their hand. And we can do that by just rotating and translating the position of that. And you might have to play around with it a little bit, but I found some good values that make sense for this one. So weapon.meshes0.translate, and this is going to change the position of it. Oh, so this is going to be a rotate. This is rotating at 1/4 turn. And let's take a peek. Okay, so it is pretty much kind of inside their hand in the palm area. The thumb is kind of going inside of it. But you get the idea, and you can position it better. You just got to play around with different translation and rotation values. And now they are holding a sword. So it's like a finale type of thing. Let's see if we can give them an animation of them swinging the sword. That would look cool. And for that, we'll go up to our spawn characters function, or rather, we'll go where we spawn the characters. So we'll just make one of the characters do it. Let's make character 2 do it. Character 2 dot skeleton dot animation groups 0 or 4 because it's going to be idling. Stop, and Well, I don't know. Let's try see what 8 does. It's a different idle pose. Let's get a good one. Let's go 11. Oh yeah, their hand is gripping, so it looks cool, and they're doing a nice kick move. So that's pretty good. This is basically everything I had to show you. There is a few things that make me think it might not be the best way to do it, but it also is the best way I've found how to do it so far. One of the things that's kind of an issue is that every time you export a part, you have to export that skeleton as well. And what is the size of a skeleton? It's kind of hard to read with the animation. It's 1.3 megabytes, which is a lot, but since these are exporting without the skeletons, this one was 18 kilobytes. Obviously, depending on your skeleton, it may have different sizes. And I was thinking all night, I was like, oh no, 18 kilobytes, like that's so many. But if you calculate it, let's say you had like 50 different types of armor and you had like 8 different slots. Like you had the head slot, the chest slot, the wrists, the blah blah blah, like the legs, the boots. So you have 50 types times 8 different slots. That's 400 parts times 18 kilobytes. That's only 7 megabytes more to your download size, which is kind of a lot, but for 400 different parts, I think it scales okay. Now, if you are like in that kind of situation, maybe you would look for that optimization of not having to export the skeleton. But yeah, I'm not in that position yet. Hopefully, one day I would be with my game that we could look for better optimizations. But for now, I think I'll just continue with this method. The other thing is that if you ever change your skeleton, you have to re-export every single part again, and that would be pretty annoying. But there are ways you can automate the exports with Python scripts in Blender or whatever software you're using. Hopefully, there's a way to automate that. And I would probably, if I was building my own assets, just build everything in one blend file and just hide the different parts. At least that's how I think I would go about it right now, but maybe with more experience that will change. Yeah, that way you don't have to open all different files and stuff and make sure the skeleton is the same between each file. You just know that's your one skeleton. But yeah, that pretty much wraps up this video on how to make a modular character in Babylon. And hopefully you learned something useful. And if you figure out a better way to do it, please post in the comments below because I'm very interested in hearing about that. So this has been Mike Silverman from the Snowden YouTube channel. Thanks for watching and have a great rest of your day. Goodbye.